Hi, good morning. In this lecture video, we are going to discuss about one of the case study of HMI design, which is called as electrospinning technique. In the previous PPT, we already discussed about the what are the user needs for HMI design and what is a human machine interfaces. Human interface is a interface between the human and the machines with the help of software or equipment as interfaces. Human interface acts as a communication between the human and a machine. Already we have discussed different types of interfaces in the HMI design, which uses visual, auditory, tactile, and physical elements to create communication level between the human and a machine. In this video, we discuss one of the example of the human-machine interfaces, which comes under physical control, which is the electrospinning technique. Uh, Now, we introduction to the electrospinning technique. Electrospinning technique is a setup which creates nanofibers from the polymer solution with the help of electric voltage. How it comes under human machine interface means it involves many parameters such as voltage, flow rate, and collected distance, in which the voltage and flow rate will be given in the syringe pump, which uses the physical control for giving the flow rate and applied voltage. Uh, the advantage of the electrospinning technique are mechanical compliance, biocompatibility, and tunable sensing. One of the main advantages of the electrospinning, it can be tunable because it contains different three parameters which can be easily changed for making tunable properties. The schematic representation of the electrospinning technique was shown in the figure, which involves the syringe pump. The syringe pump loads the polymer solution. In syringe pump, we have to given the flow rate and apply voltage. The polymer solution was connected to the applied voltage. In applied voltage, we can be increase and lower. On applying voltage, the polymer solution was converted into nanofibers and finally deposited in the collected drum. The collected drum was the nanofibers from the collected drum was taken away and was air dried to take out the clean nanofibers. The next, the breakthrough applications in the electrospinning technique are, which can be suitable for the making bio-inspired e-skin sensors, multimodal sensing systems, which involves the interaction between the nanomaterials and multi-parameter sensing parameters for a self-powered and autonomous wearable systems. Next, on-demand fabrication, which involves fabrication for personalized wound dressing and sensor patches for customized individual patients. Next, we will discuss about the key challenge in the electrospinning technique. Since the electrospinning involves three parameters such as flow rate, voltage, and collected distance, the optimizations for making clean NF are very difficult. However, we can change the each parameters to make clean nanofibers. The other challenges are production instability, fiber control precision, safety and scalability, environmental impact. The environmental impact because the polymer solution was um converted to solution with the help of organic solvent. The organic solvent may be very toxic, so which may causes the environment impact. Next is economic viability. Uh, Next, how to overcome these challenges means need of advanced systems which involves needleless and portable electrospinning platforms, improving scalability and user safety. For reducing impact environment, we can go for green materials, the eco-friendly polymers. Maybe future may be integrated with 3D printing for precise fiber architecture. Next, interdisciplinary research combining material science, electronics, and biomedical engineering expertise. Next, we will summarize the session. In this PPT, we will discuss about the example of the human interfaces, one of the physical control of human-based interfaces, which is the electrospinning technique. Electrospinning technique was used to convert the polymer solution into nanofibers. The advanced applications of the electrospinning are bio-inspired e-spin, multi-notation systems, on-demand fabrications. However, the challenges was available in the electrospinning technique, which involves production stability, fiber control precision, safety and scalability, environmental impact, and economic viability. To overcome these challenges, we'll go for advanced systems, hybrid fabrication, and interdisciplinary research to overcome the challenges in the electrospinning technique. Thank you.